Hi, my name is Jason, and I'm gonna do some coding for you. Let's try this one out. I haven't looked at this problem at all, don't know what it is. Palindrome number. Let's see. Given an integer x, return true if x is a palindrome and false otherwise. Example 1, input x equals 121, output true. Example 2, input x equals negative 121, false. Oh, uh-huh. From right to left, it becomes 121 minus, not a palindrome. Okay, constraints. Looks like it's a 32-bit integer. X equals 10, false. Can you solve it without converting the integer to a string? Let's try solving it without converting the integer to a string. Why not? Okay, because it's like easy to convert it to a string and do the palindrome thing. If we were going to convert this number x to a palindrome without converting it to a string, let's set aside for now the negative case, and let's think about what a palindrome means numerically. It means that if you have 1, 2, 3, 2, 1, for example, we have 1 in the, what is that, the 10,000th place. And then we have 2 in the 1,000th place. Why did I do that? That's hilarious. We have 3 in the, am I braining right? 3 is in the 100th place, yes. 4 is in the 10th place, and 5 is in the 1's place. Not 5. Again, not braining right. So the reason that we know that this is a palindrome is because the largest place, let's say, and the smallest place is the same. Then the next largest place and the next smallest place. This is, in math person language, that's a power of 10. Make a little function that's called get nth place from a number and n for the nth place. So we would say it's really going to be like, well, we're going to take the math.floor of that number, I guess, just divided by math.power, or I think we can do this, 10 to the n. So for example, if the number coming in was 37, it would be math.floor of 37 divided by 10, which is 3.1, 3.7, which is 3. So I think this function with a return statement, which I forgot to put in, would give me this. Very nice. That gives me the nth place. Now we also need to know what is the, because to figure out if something's a palindrome, okay, you have to be doing some comparing. You're going to compare the first to the last, and then you're going to compare the second to the next to last, or something along the lines of, let's rewrite this as compare the 0 to len minus, this is how I would do it if it was a string, len minus 1, compare 1 to len minus 2. Please excuse this nonsense pseudocode that I'm writing here. So I just need to have some equivalent of this in the realm of the number here. I have to find out what. So, strings, of course, have a length. Okay, but numbers don't. So I need to find out the highest nth place, let's say. So in other words, if I was going to, so for this number, let's just take this number for example, right? And we would say like, we're going to have like this sort of loop. So we're going to compare index 1 and index 2. Index 1 is the first character in the palindrome, and that's the last one, okay? So we say let index 0, let's call it 0, equal to 0, let index 1 equals, let's just take the example here, it's 5, right? It's not really 5. So we would have 4, we already did our lets, and we're going to make sure while I0 is less than I1, because if they're equal, it's okay, it doesn't matter. And then we would say I0 plus plus and I1 minus minus. This little for loop, what this does, just to try to explain what I'm saying, this is the length. I have two indices into this quote unquote string, which isn't really a string. The first index is where I'm starting, the first index is the one letter I'm comparing to, and then the other index is the other one I'm comparing them to, and I just want to make sure they're the same. So we would just want to make sure that like let the number at I0 be equal to get nth place I0 of the number, and then let number, this is going to be digit, sorry guys, digit at I0 makes a little more sense. Digit at I1, index 1. Do you want to say index? Do you want to spell it out? Whatever. Get nth place number, index 1. So now that's just going to, these two variables here store these two digits, and I want to make sure they're the same. If digit at I0 not equal to digit at I1, we can just straight up return false because we know it's not a palindrome. Right? And then we can return true if we get through checking all of the digits and they're all the same. This is all very nice, but it's not complete. So let's get rid of this junk down here. Let's think about this again. So I have I'm going to change this to num x. I guess I'll just keep it as x. We like x. Elon Musk likes x. Okay, x is our number, folks. In our example here, x is 1, 2, 3, 2, 1. We have 1, 2, 3, 2, 1. We compare I0 here with I1. They're the same. I0, I1 now is equal to these indices. In this edge case, they become the same, so one's not less than the other, so that means that we exit the loop and return true. It doesn't matter if the middle digit is a thing. In the other edge case, not the other edge case, what does that even mean? If it is an even number of digits, then I0 starts here, I1 starts here, then I0 is here. I mean I0 is here. And then on the next loop iteration, they switch places, meaning that I0 is not less than I1. So really, it's fine. Both odd and even length numbers will work with this equality test. I suppose if I wanted to be really a nerd, I could put commas here and put these let statements together in here, but I'm just not going to be that nerdy. So we've got a loop. I think our edge, this is the part we don't know, right? Let len equals get max nth place. This is basically needs to tell us how many digits are in this number. And remember, we are trying to do this without converting it to a string, okay? I think the way that I can do this is essentially calling get nth place over and over. So let's, why am I calling that? Get number of digits in X. I'm not even writing functions and I gotta decide, is it gonna be a closure or not? Make up your mind. Get number of digits equals num. I never know what to call variables. Num this and that. Get number of digits num. Yorpity dorp. Okay. Let's start with the first. Let's just increment some numbers. Why don't we just do this? For let I equals 0, I 1. We start at 1. I think the 0 power is 1, right? Okay, so we will start at 0. So then we say I less than 32 because we know this is a 32-bit integer. I plus plus. Okay, and then we say let digit at place equal to get nth place num I. So what this loop does is it starts with 0. What's the digit at the 0th place? What's the digit at the 1th place? They're not really the digit in the 1th, in the 2nd, and the 3rd, and the 4th place. It's 0, 10 to the 0 power, 10 to the 1 power, 10 to the 2 power. So, i.e., the 1's place, 10's place, 100th place, etc. It's finding out what the digit is. Okay, I also need to, yes, right. Okay, guess what? If the digit at place is 0, that means we can return I plus 1 because we just can. Because if it's a 1-digit number, okay, right, then we will at least get through here once because, of course, it has an nth place digit in the one's place, so we'll at least get there. I will be 0, and what we want actually is 1, the number of digits. Okay. So here's a little question I have in terms of edge cases. If I put this, right, get number of places X, okay. What am I doing here? Get rid of this. What am I saying? Digits. Okay, right. Yes. It's making more sense now. Starting to come together. Get nth place. Let's reread all our code here. It's a function. Get nth place. Takes a number. Takes n. We return the floor of that number divided by 10 to that power. So, for example, if I passed in 352 and 2 be 352 divided by 10 to the second power, which is 100, which gives me 3.52, and we get the math.4, which is 3. I'm pretty sure this is correct. Number of digits, if I pass in 924, we start at 0, we get the digit at place of no, this is wrong. Super wrong. Because the digit could be 0, folks. Okay, this is utterly and badly and stupidly wrong. We need to start... Yeah, this is broken. What we have to do is start with 32, or maybe 31. I greater than 0, I minus minus, and if it's not 0, okay. So what we're going to do is start large and go small instead of starting small and going large. Okay, so what this function here is going to do is it's going to start with getting the digit at the 10 to the 32 place, which, let's look at our constraints. I don't know, 10 to the 30, 2 to the 31. Oh, yeah, base 2, base 10. That's annoying. What is 2 to the 32 again? Well, I just don't have that memorized. But let's just say... Hold on. I wish I could just evaluate that because I don't remember it. 2 to the 2 squared is 4. Oh man. Okay. I'm not going to worry about that for right now. This is not 32 though. This is more something like 20 or something. I don't know. I need to finish thinking about this first before I try to figure out how many base 10 digits are in base 2 are in 2 to the 31. Okay? Because I don't know the answer to that. How many base 10 digits are in 2 to the 31? I could, for now, num digits cheat equals 2 to the 30, 2 to the 32. Turn it into a string. Look at me cheating. Cheating so cheatily. But the thing is, I'm not really cheating because it says, can you do it without converting the input integer into a string? I'm not converting that into a string. I'm just converting 2 to the 32 into a string. Okay, dot length. All right. So that's my cheat. And then num digits cheat. Okay. What's going on, Jason? So we need to know how many digits in base 10 2 to 32 is. I've resolved to not look at any web pages or use a calculator or anything while making this video, since I don't remember what 2 to the 31 minus 1 is. I'm going to instead convert it to a string in base 10 in this code, find out how long that is. That is the number of digits, okay? Then, the number of digits in base 10 is where we start. That's the maximum number of digits that any number in the input can have. And then we want to make sure it's greater than or equal to 0. Then we'll start subtracting. And then we're going to say, we're going to find the digit in whatever place it is. As long as it continues to be 0, we keep going down. Okay? All right, this is exhausting, but we're going to pretend, because I need to really evaluate the edge case on this and make sure I don't have an off by 1. Okay, so let's pretend that the max num is 99999. That means that num digits sheet equals 5. And our loop goes like this. I starts out being equal to 5. Let's say the number we're going to be evaluating is 365. We want to find out how many digits that is without converting it to a string. I equals 5. We start off by saying getting the nth place. Okay. Digit at place. For 365, or yeah, it's get nth place 365, 5, that would be 0. Okay. So we go through the loop again. Now we change this to 4. I think this needs to start as, I think this has to be -1. Because we really, if this is where we're at, then this is 0's place, 1's place, 2's place, 3's place, 4's place. In other words, 10 to the 4. So this really needs to start at 4. 0-based indexing, just like, just like you expect it to be. So we actually start with 4. The digit at place 10 to the 4 is 0 for this number. Then when we go to 3, it's still 0. The digit at the 10 to the 2 place is 3. Okay. Meaning that it is still I plus 1, that's correct. There's 3 digits in this number. Okay. This is so great. I think it is working. I mean, I don't know if it's working, but I think I worked through mentally the edge cases. It's bothering me that I don't know what 2 to the 31 is off the top of my head. I feel like I should know that, but also I'm not just gonna sit here while you guys sit here in silence figuring it out while you guys like stare at the screen. I'm not gonna do that. So we'll just do this. Get nth place. Again, I'm pretty sure this is correct. I just checked it. And then I should not get here. I don't even know. I'm not going to worry about it. Shouldn't get there. It shouldn't even be possible. Hopefully it doesn't crash. So, getting back to the main function, getting rid of this example, we let I0 equal to 0. I1, this is an index again, number of digits. But I think this has to be -1. Because we're talking about like kind of like indexes, like string indexes here. Okay. I really am starting to feel like this is getting there. Comparing the digits. Let's try it. Wrong answer. Oops. So let's work out what happened when the input was 121. When the input was 121, we started with that being equal to 0. That's equal to get number of digits x minus 1. Ideally, I1 would have been equal to 2. Hopefully this is correct. Then we would say, as long as, and like, I1, I0 would be equal to 0. Returning true. Why would it be returning true? This is this. Let's really quickly say something like, let's just make sure that I didn't screw this up. Let num digits cheat equal 10. You know what I mean? Let's see if like that fixes it real quick. No, it's not. That's not the problem. Might be this. Okay, hold on. Let's get back to what I was doing. This is 2. I0 is less than I1. 0 is definitely less than 2. We want to say digit I0 is that, what's it, it's actually getting, so digit I0 is, it's actually the other side of the number. I was thinking that I0 would be like one, like this left one, but it's actually the right side, the right hand one. Digit at 1's get nth place this. If they're not equal, we would be returning false. I did at some point output false. So these did not turn out to be equal. Again. Let's see if case 1 gives me a different answer. I do this. Case 1 still fails. Get nth place doesn't work. Do I need to do this? Is this the order of operations again for this exponentiation thing? No. So let's say num is 121. N is 0. Wait a minute. Okay. What I need to, okay. What I was, okay. It is modulo, I just forgot the modulo part. It's not even divided. It's like num modulo that. I don't know why I said divided. I guess I'm just, or it's that, hold on a second. If I have 121 and I want to get the get that 0th digit, I say, oh, right. I remember this now. Minus num divided by 10 minus num modulo 10 star star. That's what it is. So in other words, it's 121. It's basically 12.1 minus 12, right? So it's 12 divided by 10. It's like 121 divided by 10 minus 121 modulo 10. No. Yes. Oh. Let n equals... Oh, God. So my brain doesn't work. $121 minus 120 equals 1. Okay, 121 is the main number, and 120 is this. $120 is that number minus okay. Hang on, I've got, okay. Okay. 121 12.1 This is where you see my brain just freeze up because I'm trying to talk while thinking mathematically, and I'm not used to doing this. Okay. I want to extract the nth decimal place. So if I pass in 6, 5, 4, and 0, I want to get 4. If I pass in 6, 5, 4, and 1, I want to get 5. And if I pass in 6, 5, 4, and 2, I want to get 6. Okay? 654 divided by 1 is obviously equal to 654. 654 divided by 10 is equal to 65.4. 654 divided by 100 equals 6.54. Okay. What I want to get is the 4 and the 5 and the 6. So in this case, math.floor works fine. In this case, it does not. Why doesn't it? Because we still have this. What I want, if I just do the floor, right, I get 6, 65, and 654. I want this to be modulo 65, and I want this to be modulo 60. Okay. Sorry, not 65, 650. Right? So it's minus 654 modulo a number. What is that number? That number is, it's essentially or is it just modulo 10? 65 modulo 10. Oh. Yes. Okay. Mod 10, folks. That was it. That was a weird journey. Let's see if that did anything. This doesn't even work. Need to get rid of some and parenthesize this correctly. I don't need to do math.4 of that. I may not even have to do math.4 period. No, I have to do math.4. But let's just see. Can you just get these parentheses out of here, buddy? Yes, get rid of the debugging. All right, well, I figured out my math mistake, and I went down a really weird went to a very strange mental place. Modulo 10. All right. Wrong answer for something -1. Right, of course. This was the edge case. X is less than 0. False. All right. I mean, aside from my weird failure to see what was wrong with this, I don't know, that was weird. I hope that wasn't too boring, but I think it was. Anyway, we're done with this video.